In this video, we're going to review factoring polynomials. We're going to first look at greatest common factor, factoring when there's a difference of two squares, two perfect squares, and then finally factoring trinomials and form ax squared plus bx plus c. When you factor, the first thing you always want to look for is there a common factor in each one of the terms? If we look at this first case, we see we have 6x squared plus 2x. If I look at my number, I see each term can be divided by 2. And each term also contains a variable x. So my greatest common factor in this case will be 2x. I simply bring that out in front of my equation or expression, and I will be left with 3x in my first term. Dividing 6x squared by 2x, I'll be left with 3x. And then my second term, 2x divided by 2x, is 1. So this will be my final factored form. You can check that by multiplying your factors back together, and you should end up with your original expression. So if I multiply 2x by 3x plus 1, I'm going to distribute that 2x through, and I'm going to get 6x squared. 2x times 1 gives me 2x. And I see that I do indeed get my original expression back, so my factoring is correct. The second case, difference of squares, is a very specific case when we have the difference between two perfect squares. To see how this works, we can multiply this back out. The difference of two squares will always factor down to a plus c times a minus c. Let's go ahead and distribute that back together, that a plus c times a minus c, and you can see where that comes from. So if we have a plus c and we multiply that by a minus c, again, we're going to distribute each term in this first parentheses through. A good acronym to remember how to distribute is FOIL. So we take our first terms and we multiply them together. We get a squared. We take our outer terms, a minus c, when we multiply them. We multiply our inner terms. We get plus ac. And then finally, our last terms, a minus c squared. You can see pretty quickly that these two center terms are going to cancel out, and we're going to be left with a squared minus c squared. So whenever we have two perfect squares, they will a squared minus c squared, they will always factor to the form a plus c times a minus c, where a and c are positive roots of a squared and c squared. Let's go ahead and do that with a few examples. Again, I always want to look for greatest common factor when I start factoring. Are there any common factors in this problem number 2? And no, I do not see any. So the second thing I want to notice is I have a difference in a binomial. Is this a difference of two perfect squares? Are they perfect squares? Well, I see 64 is a perfect square, y squared is a perfect square, as is 49. So now I need to find my a and c values by taking the square root of those perfect squares. So a will be the square root of 64y squared, positive square root, and that's going to give me 8y. My c value is going to be the square root of 49, and that is going to give me 7. So when I put that in the form, factored form a plus c times a minus c, I'm going to get ay plus 7 times ay minus 7. And that will be my final factored form. Again, you can always check that by multiplying these two factors together, distributing them, and you should come back to your original expression of 64y squared minus 49. Okay, let's divide this off. Now let's show you our second example, 8y squared minus 18. Do I have any common factors? Is there a greatest common factor in this expression? Yes, they are both divisible by 2. So let's go ahead and bring that 2 up front, and I'm going to be left with 4y squared minus 9. Again, I have a binomial with the two terms subtracted. Do I have perfect squares? Yes, I do. 4 is a perfect square, y squared is a perfect square, and 9 is perfect squared. So let's go ahead and find our a and c values. A is going to be the square root of our first term, 4y squared. Positive square root is a 2y. My c term is going to be the square root of 9, and that is going to be 3. So my a plus c times a minus c. I don't want to forget my 2 that I factored out, so I'm going to put my 2 in there, and I'm going to be left with 2y plus 3 times 2y minus 3. So this is going to be my final factor answer. Again, I can distribute that out, first multiplying my 2 factors here together, and then each one of them by 2, and ensuring that I go back to my original expression to check my work. So the final case is when I have a trinomial in the form ax squared plus bx plus c. We're going to first look when our first term a is equal to 1. So when I look at this trinomial, I know from working FOIL backwards that I'm going to have a c term in each one of these binomials, because when I multiply c by c, that's going to give me c squared. Since this is a 1, I can only have a c and a c here. So to get my second 2 terms, I'm going to look at my number 18, which is in the c place, 18, and I'm going to say, what are the factors of that will add up to give me my center b term, or in this case, a negative 9? What are the factors of 18 that add up to give me a negative 9? Well, let me write down my factors of 18. I have 18 and 1, I have 9 and 2, and I have 6 and 3. I also know that this is a positive, but they have to add up to be a negative. So the only way that can happen, the factors have to add up to be a negative, is if the factors are both negative, because 2 negatives multiplied together will give me my positive 18, and then added together will give me a negative number. So which one of those factors add up to give me a minus 9? I can see it's a minus 6 and a minus 3. So I simply want to put those in there. So I'm going to do a minus 6 and a minus 3. Now I have my final factored form. Let's go ahead and check that one. So if we multiply our first term, c times c, we're going to get c squared. Let's do our outer terms, minus 3c. Our inner terms, minus 6c. And our last term is a plus 18. And let's combine our center terms. We get c squared minus 9c plus 18. And I see that does indeed bring me back to my original expression. So the correct answer for this final factor form is c minus 6 times c minus 3. Let's go ahead and do another one. In this case, I notice I have a common factor. Always want to take those out first if I can. In this case, I have a common factor of 2. And I also have a variable in each term m, so I can factor out a 2m. So let's go ahead and do that. So I bring that out front, and I will be left with m squared in my first term. Divide 6m squared by 2m, I'll be left with a 3m. And then my final term, 56m divided by 2m, I will be left with a 28. Okay, now I want to factor this trinomial that's in parentheses. So again, I have my 2m out front. I know since my first term is 1, I'm going to have an m and an m in my binomials, because again, multiplying m times m will give me my m squared. So let's go again, have a look and see what are the factors of a negative 28 that are going to add up to give me a negative 3. So let's go ahead and just start listing the factors. I'm going to have a 28 and 1. Well, I know that's not going to add up to give me a negative 3. One of them is going to have to be negative in order to multiply together to give me a 28. So I'm going to make my larger one a minus, because I know when I add them together, I'm going to have to add up to get a negative number. So I'm going to make my largest factor the negative and my smaller factor the positive. So negative 28 and 1. Let's try 2 and a negative 14. If I add those up, no, they do not add up to a negative 3. So I'm going to keep going. not divisible by 3, but it is divisible by 4, 4, and a negative 7. So I notice that if I add a negative 7 and a 4, I'm going to get a negative 3. They're going to add up to give me a negative 3. So I'm going to go ahead and put those factors in here, minus 7 plus 4. And this will be my final factored form. Let's go ahead and check that quickly. So if I do a minus 7, m minus 7 times m plus 4, and I'm going to go ahead and multiply that out with my distributing that, which is simply using a FOIL. I'm using my FOIL acronym. So I do m times m, I get m squared, my outer terms plus 4m, my inner terms minus 7m, and then finally my last, a negative 7 times a positive 4, I'm going to get a negative 28. These two center terms will add up to a minus 3m and then a minus 28. So now I need to distribute my 2m through. So if I multiply 2m times m squared, I'm running out of room here, minus 28, excuse me for running out of room. If I distribute that 2m through and multiply it by each term, I'll see that I end up with 2m cubed minus 6m squared minus 56m. And I do indeed go back to my original expression. So this is going to be my final factored form. All right. Now let's use or have a look at factoring polynomials when our first term is not equal to 1. Okay, so let's look at this when our first term is not equal to 1. We're going to use factor by grouping in this case. So factor by grouping, if you recall, we take our C term and our A term, we're going to multiply those together. So we're going to get A times C equals minus 48. And we want to know what are the factors of that, factors of A times C that are going to add together to give me my B term, or in this case, 13x. Okay, so let's have a look at that and see what we get. I'm going to make my little x over here, and I'm going to put my minus 48. This again is A times C. And I want to know what factors of minus 48 are going to add up to give me a positive 13. So again, I know I have a negative here, so I'm going to have a negative times a positive in order to get a negative, but the sum of them has to be a positive number. So I'm going to make my larger factor the positive number. So if I do 48 times a negative 1, that does not add up to give me a 13. If I do 16, I'm sorry, I jumped the gun here. Let's do 2, a negative 2 times 24. That does not add up to give me a 13. If I do a negative 3 times 16, which is factor 48, that indeed does add up to give me a positive 13. So I'm going to take these factors. I'm basically going to replace my 13x with these factors. So I get 2x squared, and I'm going to replace that 13x by the factors of A times C that add up to give me 13. So I'm going to get 16x minus 3x minus 24. So you can see I just took those factors, and if you add this together, it simply adds up to give me 13x. Now I'm going to group this into the following groups, my first two terms and my second two terms. And I'm going to look for common factors in these binomials. So in my first binomial, I see I have a common factor of 2x. And in my second, I have a common factor of a negative 3. So I'm going to go ahead and factor that out. In the first case, 2x, and I will be left, when I factor that out of my binomial, I'm left with x plus 8. In my second binomial, I'm factoring out a negative 3. So I will be left with a positive x when I bring out a negative, plus 8. Now I can see I have a common factor of x plus 8. I'm going to bring that out front. And what I'm left with is 2x and minus 3. So this will be my final factored form. And again, you can check it by multiplying it out. X plus 8 times 2x minus 3. And if I distribute that through, I get 2x squared, outer terms, minus 3x, my inner terms, plus 16x, and my last terms, minus 24. And I am back to my original expression. So this indeed is correct. So you can kind of see how this grouping is basically just working this backwards. You're getting to this state, and then you're grouping these two binomials and factoring out greatest common factor. So you can always use grouping when you have trinomials in the form ax squared plus bx plus c when your first term is not equal to a. But if you think you're pretty comfortable with factoring and you just want to kind of guess and check, go a little bit faster if this works faster for you, let's have a look at this one and see what we can do with it. So we'll look at this. We know from distributing or FOIL that in order to get 3x squared, I'm going to have a 3x times an x. That's the only way I can get 3x squared in my first term. So I know it's going to be 3x times x. My third term is going to be a positive. So it's either going to have a positive times a positive or a negative times a negative. Well, I want my center term to add up to be a negative, so I know this is going to have to be 2 subtractions or 2 negative values in this second term. Now I'm going to have a look at my factors of 6. So I'm going to look at my factors of 6. I just have 6 and 1 and 3 and 2. I know they're going to have to both be negative. So I can simply start substituting those in here and then multiplying it back and checking which factors will give me the correct expression, which factors are correct, and when I multiply them back will give me my correct 3x squared minus 11x plus 6. I can also look at the factors and think this through a bit. So I know that I'm going to have to multiply, when I do my outer, I'm going to have to multiply 3x by one of the factors and then x by one of the factors, and the sum of those are going to have to give me 11x and negative 11x. Negative 11x. So let me think. Let me try to put a 3 here and a 2 here. So I'm going to try this first one, and let me multiply that back out and see what that brings. So if I multiply that out using FOIL, I'm going to get 3x squared, my outer terms minus 9x, my inner terms minus 2x, and then my last terms positive 6. So I see that I do indeed get 3x squared minus 11x plus 6. I get my original expression. So this is the correct factored form, 3x minus 2 times x minus 3. So the guess and check method, you're just going to go ahead and substitute in different factors for your third term, multiply them out until you find the ones that are correct. So I hope this video helps. Good luck with factoring.